Okay, so we've got hydrofluoric acid has an acid dissociation constant of 6 times 10 to the minus 4, and at equilibrium the concentration is 0.025 molar. Okay, so our equilibrium expression is going to look like this, or our balanced chemical equation is going to look like this. Our equilibrium expression then is going to be products over reactants. And we don't include water in here as it's our solvent, so it's basically everywhere. Or it's the same, it'll be the same top and bottom, and so it'll cancel. And so that's our equilibrium expression for HF. Now, depending on the values given will be how we use to solve this, but here we have our equilibrium concentration, so that means we already have this value here, so that's this, right? So there's a difference between if we're given our initial concentration or our equilibrium concentration. So that's good. And our Ka is given in the question of 6.8 times 10 to the minus 4. And now we can solve for our H3O plus concentration by recognizing that this is a 1-to-1 here. And so our H3O plus equals our F minus. And so this value must equal our H3O plus concentration squared over our HF concentration, which is 0.025 molar. I'll get rid of that actually. So the units are kind of funny with equilibrium expressions, so it's best to just drop them. Okay, and so H3O plus is equal to 6.8 times 10 to the minus 4 times 0.025, all square rooted. And if you work through this, you'll get 4.123, and then you can add in units at the end, appropriate for the quantity. And then our pH is, that would be a giant concentration, 4.123 times 10 to the minus 3. Okay, and then our pH is just the negative logarithm of this value. Again, logarithms don't like units, so we're just going to drop it there. And so 2.385. So our pH for the solution is 2.385. Alright, so now checking through the solution given here. So there's our equilibrium expression that we had above. And then there's our pH. They do go through an explanation. So there's our balanced equation where they've, I guess, swapped A for F. But that's just a more general balanced equation. So this is for fluorine, or HF. You could make an ice table, but there's no point. Although it is showing you that at equilibrium, we're given our equilibrium value and the x's. showing that H3O plus and F minus must have the same concentration. So we get our value there and our pH. So that looks good. Okay.